My name is Malte Lenz. I'm one of the developers of Wolfram SystemModeler at Wolfram Core in Sweden. And this is the talk Wolfram SystemModeler in the cloud with the subtitle Integration with Wolfram Language. So let's get started. I'm first going to have a short introduction, then I'm going to talk about having SystemModeler simulations inside the Wolfram language. Then a little bit about the simulations in Wolfram Cloud. And at the end, I'm going to talk a little bit about deploying models for easy consumption. So let's get started. As an introduction, this is a preview. Nothing you will see here is going to be final. Nothing is shipping. So expect stuff not working, expect crashes. I would be surprised if everything works all the way through. With that said, we welcome feedback. If you're interested in deploying your simulations to the cloud, running stuff in Wolfram language, talk to me after this presentation, and we'll incorporate that going forward. So let's get started. So this is how something could work today. So let's say Alice, she buys SystemModeler because she wants to model something cool, like a helicopter. So she buys SystemModeler, she creates a very cool model of her helicopter, and then she wants to share this helicopter model with Bob, who wants to run a couple of different scenarios. So Bob also buys SystemModeler to be able to run the model, and he then runs his scenarios. For example, he wants to check how thick should the blades be, how fast should they be rotating for the whole thing to fly. So that's what we basically have today. So we have a Mathematica package that's shipped with SystemModeler, so you get analysis and simulation inside Mathematica. But you do need a full SystemModeler installation behind the scenes. You do need to buy it currently to do simulation and analysis of these models in Mathematica. What we have planned is to make SystemModeler simulations built-in part of the Wolfram language. So what that means is when you buy Mathematica, for example, you get a version of the SystemModeler kernel, what's running behind the scenes, with Mathematica, with the Wolfram language, and you get a deeper integration into the language. And of course, it means that anyone that has Mathematica can run your models you have created in SystemModeler. So for our scenario, that means Bob doesn't have to buy SystemModeler anymore. He can just take this cool helicopter model and run his scenarios in Mathematica. And of course, if something is in the Wolfram language, it will end up everywhere the Wolfram language is, which also means the Wolfram Cloud products. Well, there are some security details. I mean, you can do all kinds of stuff in model, like run C code. Of course, we can't allow that on the public Wolfram Cloud. And there are some infrastructure adaptations, but pretty much it's in the Wolfram language, it's going to be on the cloud. So what this means for SystemModeler and SystemModeler simulations and models is that everything of that is going to be available in cloud notebooks. And that opens up a lot of possibilities. For example, you can now access simulations of SystemModeler models on all kinds of devices, like everything that has a web browser, or even your iPhone or iPad. So we get another person in our scenario, Carol. She can run some different scenarios, but she just wants to run a couple of scenarios with this helicopter model. She doesn't care about installing the desktop Mathematica. She just wants to run a few scenarios. She just opens her web browser and runs these scenarios in her web browser in the cloud notebook. So I have a little question mark here, so let's hope we can actually have a live demo with all the Wi-Fi here. So let's see if I can actually magnify this as well. So this is just Firefox. It's running a tab here with the Wolfram Cloud, or a special version of it actually. And what you see here is a bunch of commands for interacting with SystemModeler models and simulations. So I'll start by loading the package. This is not going to be a package once it's integrated, but we're not there yet. So I'll have to load this package. And this is just to see if everything seems to be working. So I could get system equations for this hello world model. It's just a very simple equation. So stuff you can do with this integration is, for example, if you have a model of an inverted pendulum, you can get the diagram for that. And it has to go to the server and fetch the diagram. But once it does that, you get the diagram. So you have your motor, you have a controller, a gear, and your pendulum. So everything of this, I mean, you evaluate everything in your web browser, but you get it running on the cloud. So you don't need to install anything on your computer. But of course, you can not only look at diagrams, you can also simulate stuff by doing WSM simulate. And you get a simulation data object back. And you can plot stuff from that. For example, the pendulum position and the pendulum position and this controller switch 1.y, cryptically enough, is the reference point for this pendulum position. So you can see it following the reference point, which changes with steps up and down, with some overshoot, but the controller is pretty good. So that's one of the things you can do. You can also do other stuff like take this model of an axis that rotates but is a little weak, so it's going to start vibrating. You can linearize that model. You get a state space object out, and you can do a Bode plot, for example. Whoops. And see what the resonance peaks are. So you probably should look to it that it doesn't rotate at like this speed, because that would not be good for your axis. So this is the kind of analysis you can do in any Wolfram language product once we have released this. So the first live demo went okay. Let's move on. Here are the backup slides. So another thing you can do is when you have all of this in the cloud infrastructure, you get a lot of things for free, so to speak. Things you could do, you can create the simulation API. Just a simple URL, when you call it with parameters, you get something back, like data from a simulation, or a plot of a simulation result with your specific parameters. You can easily share your work with other users. You can just send them the link to your cloud notebook, or deploy something to the cloud and share the link with them. And they can access it on any device. Or you can embed simulations in your own web pages. So say you want to present your results of your helicopter model. You can have a whole web page describing your helicopter and just embed the simulation results right there. They can even be interactive, so the person who reads this web page can drag some sliders and see what different parameters how they will affect the helicopter. And that's the last point, deploy interactive simulations on the web. So we get another person, Dan. He has to sign off on this final helicopter. So he wants to check the final scenario, what will actually happen when you run this scenario. And he definitely doesn't want to install Mathematica, because he's always busy and he only has his phone with him. So he can just check this on his phone because it's all deployed in the cloud. So time for the second live demo. And here I have a bunch of different pages showing different examples. So here's one example. If we look up here, unfortunately I can't magnify that, but it's basically a web address with an object name, and then it has a bunch of parameters. It says time equals 150 and pipe length equals 1. So this simulates two tanks that are connected with liquid in them. There's a connection pipe in the bottom, and one of the tanks is leaking. So these two parameters, they say how long do you want to simulate and how long is this pipe going to be that connects the two tanks. So for example, I can make the pipe longer and just reload the page with the other parameters, and I get a different simulation. But now it didn't actually reach any kind of steady state, so I need to simulate it for longer. So let's simulate for 300 seconds instead of 150. And it does the simulation and returns the plot. So that's an example of an API where you can easily run simulations on a predetermined number of parameters. You know which parameters you're allowed to set, and you can just call them, and this can be used programmatically from other languages, for example. But you can also do it interactively with a form, for example. So this is the same example. But now you have a form with a slider. You can choose the pipe length, and you can choose the simulation time. For example, 150. Yeah. And then you just run simulation, and you get a plot back. Same way. And if you want to do it again, you can go back and try something else. And here you can probably use the thing that Steven showed yesterday on the keynote, the auto-updating, auto-submitting form, so you didn't get to another page. Another one, okay, let's see if this works, is actually an interactive manipulate. So you can run simulations in the background where you drag your slider, and let's hope it updates. It should update, maybe not. Let's try a refresh. Yep. You can drag the slider and it will update the plot. And what it does when you release the slider, it's actually doing a completely new simulation in the cloud and just returning the result to you. So that way you can quickly check different configurations and what the result will be. And I wanted to show this, but it doesn't seem to load the right thing in my embedding. So the idea is you have your own custom HTML page, and you just embed one of these manipulates inside it. Right, so I'll just skip that one. Okay, actually I can show the screenshot because I have backups. So this is what it's supposed to look like. So it's a custom page, and you have this manipulate inside it, just right in the middle of your page, and you can drag the slider, and the 3D plot was supposed to update. Thank you for listening.